Well, you okay?
Yeah. Angie?
Yeah, okay, Vic.
Hi. I'm Vic Morrow, just working on a new segment of our combat television series. You know, the popularity of this weekly show proves that World War II still has a very firm hold on the minds and the memories and the imagination of the American people, as it should. It was the greatest war this nation has ever fought, and it brought sweeping changes in the techniques and the tools of war itself. But despite the dramatic changes, World War II confirmed what every war before it had demonstrated, that the soldier is the ultimate of all weapons. Yes, the soldier, the GI himself, is the ultimate weapon in the American Army. But still, it must be put in its proper perspective. For in none of his wars has the soldier existed or fought in a vacuum, facing the enemy only with his own cunning and his own fists and his own stout heart. He has always had a lot of other things going for him besides. Superior tactical concepts, superior training, superior equipment. The American GI, in all his triumphs, was the sum of all of these. And so he is today in an army sharpened and strengthened by technological advance. The soldier still is the ultimate weapon, the one indispensable quotient in the equation of military supremacy. But the fruits of technology's continuing revolution have increased his fighting potential to a degree scarcely imagined by the generations of men who served before him. So the American fighting man today, like those in the long tradition which culminates in him, is effective not only for what he is, but also what is represented in his stance of readiness, the training which shapes him, the organization which guides him, and the logistical effort which provides him with more power than any soldier has had in the history of arms. Our story for today deals with one vital facet of the overall effort, the test and evaluation of weapons and equipment to assure that the American soldier receives only the best, to maintain, in short, the validity of a soldier's warranty.
The test and evaluation program to provide today's soldier with arms and equipment is geared to the momentum of the forward thrust of technology to make sure the soldier's warranty stays good. For what's at stake is the ability of the United States Army to maintain a position of superior strength in order to carry out its vital mission of deterring war by being prepared to fight and win if war should come. As industrial science rolls up new discoveries which make possible new equipment, which in turn would increase the Army's effectiveness, those very items become vital to the Army's strength and to the nation's security. So they must be moved as quickly as possible from the drawing board to the assembly line and then to the field. And all of it, all of the advanced and sophisticated machinery of modern war must reach the field with the full assurance that it operates precisely as it's supposed to operate when it's put into the hands of the soldier who will use it. There's only one way this assurance can be given: by testing the materiel itself. Every item designed and developed for Army use, testing it under conditions as close as possible to those of actual combat. This all-important job of testing is the responsibility of the U.S. Army's Test and Evaluation Command. Headquartered at Aberdeen Proving Ground in Maryland, the Test and Evaluation Command is relatively new to the Army. It was born in 1962 in a reorganization designed to streamline the structure of the Army and adapt it more closely to the changing conditions of the time. The result is an organization of more than 20,000 soldiers and civilians working with facilities in installations which extend across the nation and from the tropics to the Arctic, all assembled into one great complex devoted to an extensive and objective evaluation of all materiel proposed for use by the Army. Operations, mission, and facilities are closely related. Some of the installations are major testing ranges and proving grounds. Here, the prototypes of new equipment are given their first major tests to determine how they perform outside the laboratory in a field environment. Called engineering tests, these are conducted by teams of military and civilian engineers and technicians. Although the conditions of testing are controlled, they simulate the severity of tactical environments. This is the XM656. It's being developed to satisfy the need for a vehicle which can carry cargo, personnel, and weapons. The engineering tests of this vehicle are representative of those given others of its class and type. To do the job it's supposed to do, this vehicle has to be able to do a lot of rough traveling, carrying its payload over all kinds and conditions of terrain, through mud and sand and snow, up hills and down, and across rough country. And it has to be able to swim besides. Theoretically, of course, this is all quite possible. That's why the vehicle was developed in the first place, as soon as advancements in automotive engineering had demonstrated the feasibility of producing it. But the step from feasibility to performance is a long one. That step is taken in the engineering tests given on Aberdeen's specially designed courses, where the XM656 faces some 7 tests simulating conditions which it was designed to meet. How well it performs and measures up to specifications is determined by appropriate instrumentation. Before they're completed, the engineering tests on the XM656 will determine a lot more than the ability of the vehicle to take rough traveling. Its maintenance, its transportability, these and more will be evaluated. Not all Army materiel, of course, gets the same kind of going over in their engineering tests. A cargo carrier has to be able to do one kind of thing, a rifle has to do another, a missile another, a tank another. But every item, every single item in the Army's arsenal is developed to meet certain specifications, and the engineering tests for each determine whether or not those specifications are met. Other major centers for engineering tests are White Sands Missile Range in New Mexico, where rockets and guided missiles are tested. The Electronics Proving Ground at Fort Huachuca, Arizona, testing center for electronic warfare equipment and other items involved in communications, combat surveillance, avionics, meteorology, and automatic data processing. Dugway Proving Ground in Utah, where engineering tests determine the effectiveness of items in the field of chemical, biological, and radiological warfare. At Jefferson Proving Ground in Indiana, and at Erie Proving Ground in Ohio, acceptance testing is conducted on production munitions. A tenant at Edwards Air Force Base in California, the Army Aviation Test Activity performs engineering flight tests on Army aircraft and associated equipment. Despite their exhaustive and rigorous demands, the engineering tests are not the only ones which are given. For these are tests under controlled conditions, and the scientists and engineers who conduct them, although they're experts in their field, are not the men who will be using the equipment. The ultimate weapon, the soldier himself, is the user. So, in other installations around the country, all new items of materiel are subjected to rigorous tactical type tests by troops in the field under conditions as close as feasible to those of actual combat. These are called service tests. They're designed to determine how the equipment actually stands up in the hands of the troops who will use it, and also how compatible the equipment and the soldier are. At Fort Bragg, North Carolina, the Airborne Electronics and Special Warfare Board conducts service tests on a number of varied items. Equipment used in special warfare That involved in air drop and air transport, certain items pertaining to combat surveillance, and Field Army automatic data processing equipment, and it also tests communications for the Field Army. This is a piece of communications equipment which illustrates the Army's exploitation of technological advances. It's the transmitter of a miniature lightweight radio set designed to give the squad leader in the battle area radio contact with his men. Up to this time, radio communications has been possible only down as far as the squad. For communication with his own men, the squad leader has had to rely on hand signal or voice. But this handheld transmitter, with its telescopic antenna, is intended to carry his voice as far as a mile. Service testing is also conducted at Fort Knox, Kentucky, where the Armor Board evaluates armored vehicles and equipment and some engineer materiel in terms of the men who use it. Fort Sill, Oklahoma, home of the Artillery Board, where troops test artillery weapons and accompanying equipment. At Fort Benning, Georgia, where the Infantry Board makes a similar kind of evaluation on weapons and other equipment used by infantry units and personnel. Fort Rucker, Alabama, where the Army Aviation Board conducts service tests on Army aircraft and allied Army aviation equipment. At Fort Bliss, Texas, where the Air Defense Board conducts service tests on weapons and other types of equipment used for air defense. Fort Lee, Virginia, is headquarters for the General Equipment Test activity. The items tested here include quartermaster materiel, which dictate a somewhat different testing pattern. For quartermaster materiel actually means the soldier's own personal equipment, what he eats and wears, what he needs to live with. Consequently, both engineering and service testing are conducted on these items. The General Equipment Test activity is also responsible for the testing of rail equipment and vehicles and materiel related to transportation. In both engineering and service testing, there's yet another determination to be made, the effect of environment. Its mission today requires that the Army be prepared to meet any contingency, to fight any aggressor under any conditions and in any part of the world. So must the Army's weapons and equipment. Normally, it's not logistically feasible to compartmentalize them, to develop some items for use in cold regions and others for hot areas. What the soldier uses must be as versatile as himself and as adaptable to environmental extremes. Therefore, the materiel has to be tested in those extremes. No weather laboratory has ever been built which can duplicate nature's own. so the Army has taken advantage of the facilities nature offers. Included in TCOM's organization are 3 major environmental test centers where materiel of all kinds can be evaluated against some of the worst of weather's effects. In the Panama Canal Zone, the Army's Tropic Test Center studies the effects of the muggy heat of the jungle. At Yuma Proving Ground in Arizona, tests are made in the intense dry heat in the sands of the desert. At Fort Greely, Alaska, the Army Arctic Test Center evaluates equipment in the bitter cold of the Arctic. Testing of Army materiel does not begin or end with the engineering and service tests which TCOM conducts, for testing is a continuing, never-ending process. It begins in the laboratory. Laboratories all over the country, where dedicated scientists keep a constant search going for new secrets which can be exploited to the Army's benefit, for lightweight metals and plastics, materials of all kinds, new systems, new techniques which will reduce the Army's load or increase its speed, improve its voice, or augment its power. This adventure within the laboratory is not within the Test and Evaluation Command's area of responsibility, but it's well within its area of interest. And TCOM personnel are kept aware of every stage of an item's development, from laboratory breakthrough to industrial fabrication. The Test and Evaluation Command's participation in the testing picture can actually begin earlier than the engineering tests. As a service to the developer when he requires it, TCOM uses its facilities, its personnel, and its know-how to conduct some of the tests called engineered design tests, which must be satisfactorily completed before the engineering tests are undertaken. TCOM becomes involved in other kinds of testing, too. For instance, its evaluation against predefined standards of the prototypes developed by 3 manufacturers competing to produce a new light observation helicopter for the Army. Even after an item has passed all its tests and becomes part of the Army's inventory, it still is subject to periodic examination. Ammunition, for instance, is tested regularly to make sure that time brings no deterioration in quality. The Test and Evaluation Command, then, in effect, is involved with an item of Army materiel during its entire life cycle, involved in a program of testing so exhaustive and so complete that no deficiency should escape detection. TCOM does not attempt to correct whatever defects it uncovers in equipment it tests. Its responsibility is only to discover and report them. This spectacular equipment offers an example. It's called the Mobile Floating Assault Bridge Ferry and is made up of components which are self-contained units designed to travel with armored columns and provide them with the capability for water crossing. Where just a few vehicles must cross, the units connect in the water to form a self-propelled 60-ton ferry. In larger scale operations, where it's necessary to move a continuous column across a river, the units can form a 60-ton capacity bridge. 16 units thus joined can form a 400-foot bridge structure in less than 1 hour, as compared to the 5 hours which it normally takes some 400 men to construct a 400-foot pontoon bridge. In the tests conducted in the water, everything worked fine. But on land, trouble developed. A joint in the drive shaft, which permits the wheel to retract into the hull when the unit's in the water, failed during the road test and immobilized the unit. But as soon as the trouble was discovered, it was reported to the developer, who immediately took action to correct it, so the Army could have its sorely needed bridge equipment as quickly as possible. Not all endings are so happy. Sometimes testing reveals defects in an item that subsequent development proves cannot be corrected. Whenever this happens, the defective item does not reach the Army's inventory. For it's certain that no soldier in the United States Army will ever be issued any weapon or item of equipment until it can be turned over to him with full confidence that it works and that it's safe. In this certainty lives the spirit of TCOM's mission. But the story of TCOM is not yet complete. For essentially, that story is how this vast complex, stretching across a continent and embracing facilities that span the spectrum of the conditions of combat, how all this is brought into operation in the testing of one item. This is the Pershing ballistic missile, now an invaluable weapon in the arsenal of the field army. The record of what this weapon and all its components went through at White Sands Missile Range, the U.S. Army Artillery Board, Aberdeen Proving Ground, and in Alaska, before the final stamp of approval was put on it, sums up generally how all the diverse elements and facilities are tied together into a cohesive testing pattern. As we have noted, not all tests are the same. The number of them and the length of the testing cycle are variables which depend on the requirements for each item. But thoroughness is a constant. These are programs and plans prepared by the Test and Evaluation Command for weapons and other equipment now undergoing tests or soon to begin. These were drawn up long before the first prototypes were out of the developer's plant, and others similar to these are being prepared right now in TCOM headquarters. In all of these, thoroughness, designed to determine that the item meets the requirements of the soldier who will use it. That kind of thoroughness is the basic demand upon which the test plan is built. Centralizing and directing all this planning in one headquarters makes it possible to develop a general format for testing which is based on thoroughness. Techniques made possible by centralized direction, such as early preparation and coordination of plans and concurrent testing, result in an assurance of adequate and proper testing, elimination of unnecessary duplication, and an overall increase in efficiency. And these, in turn, reduce the lead time from development to production, which means that critical equipment reaches the field in the shortest possible time.
The payoff is with the American soldier, the man in whom we all put our hope and faith. And his job is a big one. His responsibilities as he keeps his watch during this long night of uncertainty and danger are enormous. He deserves the best. And the job of the United States Army's Test and Evaluation Command is to help see that he gets it.